So square root functions, it's actually the inverse of quadratic, and that's why it's super similar. Okay, so when we graph it, let's do the parent function. The parent function is just the square root of x. It's the simplest square root equation possible. So square root of x, oh, not squared. When I go to my table, watch this, guys. What happened? And watch if I keep going that way. What does it keep saying? Error. So we can't obviously plot that. We don't know how. But if you remember, do you remember when we were simplifying square roots and they had a negative? What did we call that? We called it imaginary. So this is the inverse of your quadratic, but half of it's imaginary, which we did talk about during that unit. So we can't plot the errors, so we always go to the first point after error, and that's where we start. So this is the only graph, y'all, that we're going to be dealing with that has a starting point. Okay, all of the other ones are going to like continue at least both directions all the time. This one does not. Okay, so knowing that, I have the point 0, 0. And then I have the point 1, 1. Are we going to worry about these ugly decimals? No. Only plot your pretty points. Do not try to guesstimate 1.4142, whatever. Okay, so the next pretty point is 4, 2. And my next pretty point is 9, 3. And it obviously keeps going, but those don't fit on my graph. Like 16, 4 does not fit on my graph. Okay, so I'm not going to worry about it. So it starts here, and it goes that way forever. Now, the reason we call it imaginary, you don't have to write this down, but I want you to see it, is because if I continue the other side, now doesn't it look like a sideways quadratic? Because it's the inverse. It's supposed to look like it reflected itself over the x equals y. So this is the imaginary side that we don't have to worry about in this unit, which is kind of nice, okay? So domain of just the blue line, ignore the green. What's the farthest left this goes? 0. And what's the farthest right it goes? Forever, infinity. What's the lowest it goes? 0. And what's the highest it goes? Infinity. Now, it doesn't go high quickly, but it is going up forever, just super slow, y'all. Now, vertex, I know it's not the same as the others, but it's where it would be. So it's literally that first point after error. So what was our first point after error? 0, 0. And is this one increasing or decreasing? Increasing. What do you think your graph looks like? Some people say half of a sideways U, because that's like what we say about quadratics, half sideways U. I'm weird, and I think it looks like the top of a lowercase r. You know how your r, you have like that tall line, and then you have this piece? That's what I think it looks like. Is that weird? Like you have a lowercase r, that's what it looks like. Right? Okay, that's what I think. Calculator steps to do your square root, you hit second x squared. Now, IHOD over here, IHOD, your inside this time is under the house. Over is outside the house. And it's exact. Okay, so that's the difference. Last, in quadratics, it was inside the parentheses. Now it's inside the house. Yes? But y'all, A is the same thing as it was in quadratics. H is affected the same way as it was in quadratics. K is affected the same way it was in quadratics. Okay? It's pretty much the same, it's just shaped differently. Yes? Okay, so knowing that, let's look at these. And then again, some of them we're not going to do all the way through because it just becomes silly and repetitive. Okay? So if we look at this first one, we're going to type it in our house. Now what I want you to realize, second x squared, x minus 2, what do you notice about this plus 3? It's outside. What do you notice about my blinker? It's still inside. So when you're still inside, you have to hit the right arrow. See how I'm not inside the house anymore? Please make sure you do that. If you don't, it's going to give you the wrong answer. Okay? So then I'm going to go to my table, and I'm going to find error. Oh, I found it. Okay, my first point after error is where I start. So I have 2, 3. Over 2 up 3. And then I have 3, 4. And then I have 6, 5. And my next point is off the graph, so it's somewhere over there. So how did this one transform? Up 3, right 2. Could I have figured that out from the equation? Yeah. Did it compress? Did it expand? Did it reflect? No. This is it. So C stands for vertex. What's my vertex? What was the first point after error? 2, 3. Now, domain, what's the farthest left this goes? Look at just the x's. What's the farthest left? 2. See how it goes all the way to 2? And then it goes right forever. What's the lowest it goes? Only look at the y's. 3. And it goes up forever. Slowly, but forever. Does it have an x-intercept? Does it have a y-intercept? Do we put 0? No. What do we put? None. Or no, or an x, but don't put 0. Do y'all see what I mean? Is it's pretty much all the same stuff. It just is a different shape. Okay, so now we're going to look more just at the graphs and the transformations, and then that's it. Yes? Okay, so knowing that, looking at this one, what do we know is going to happen right away? It's going to flip. It's going to have a vertical reflection, or reflect over the x-axis. And what's that plus 2 telling me it's going to happen? Left 2. It's opposite. So I know, did it go up or down? No. So when I hit graph, we're going to sketch these. Look, it went left 2, and it goes this way. Right? I just plotted my vertex and then I sketched. Not going to lie. So the only thing that really changes is, first off, is it increasing or decreasing? It's decreasing now. Okay? But my domain and range change a little bit. Well, what's my domain? What's the farthest left it goes? And what's the farthest right it goes? Positive infinity. Because it's still going to the right, which is positive. What's the lowest it goes? Isn't it going down forever? So my range starts with negative infinity. And what's the highest it goes? What's the height of this point? 0. Do y'all see the difference in your range when it's reflected? Okay. It does have an x-intercept, it does have a y-intercept, but we know how to find those, yes? Dang it, my computer hates me. Okay, any questions on that one? Okay, so looking at this one, what's going to happen? Vertical expansion, it's going to grow faster because it's a bigger number, right? So we call that a vertical expansion. And what does that minus 5 do? Down 5 because it's outside. Now, if I graph this, 3, we're going to sketch it again, x minus 5. Look what the vertical expansion does. You see how much faster it was growing? Okay, that's how we know it's a vertical expansion. So it went down 5. And then it just like got really big really fast. Do y'all see what that looks like? Okay. So what's going to happen on this one? Vertical compression. And what happens on what's that plus 6 tell me? Left 6. So without even graphing, I know it's going to go to the left 6. And it looks like this when I sketch it. See how it's super flat? Okay, so it's still going up forever. That doesn't change your domain and range, y'all. It just changes the graph. It's smooshed. Yes? Any questions with this? Pretty simple? Okay, cool. This is what you're working on.